Chapter 2, Creating Fertile Soil. In this chapter, we'll learn nutrient supply and demand, testing your soil, meet the nutrients, identifying deficiencies, soil acidity, organic matter, the key to balancing nutrients, and forms of organic matter. For soil to be ideal, it's not good enough for the physical properties described in Chapter 1 to be good. The interlocking chemical properties that create fertility also must be in good shape. Rich loam is created by physical and chemical properties working together. Fertility means more than just pouring on fertilizers. Plants need a varied and balanced diet, but nutrients are of no use unless they're within reach of a plant's roots or leaves. The Great Balancing Act. If nutrients aren't in the right balance, plants can't use them even if they are all within easy reach. Too little of one nutrient can partially starve plants by limiting their use of other nutrients. Too much of one nutrient can lock others out of plants' reach. Soil that's very acidic or alkaline locks up several nutrients at once. The best loam is not too acid, not too alkaline, and has a good balance of all essential nutrients. The largest part of a plant's diet is the major nutrients, those used in large quantities: nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. Plants also need micronutrients: iron, manganese, copper, zinc, and boron, and molybdenum, but in minute amounts. Overdoses of any micronutrients can be toxic. Organic matter is your ally in the Great Balancing Act. It provides many, if not all, the minor nutrients plants need, often in just the right balance, plus small amounts of all major nutrients. It releases the nutrients slowly, matching plant needs and helping to prevent an overdose. Finally, organic matter ensures availability by helping maintain the right acidity balance. Nutrient supply and demand. Nutrient availability is a constant give and take. In addition to sources supplying nutrients and uses removing them, there are several interacting factors that can affect supply and demand. Each is explained in the chart on the next page. Sidebar: did you know nutrient reserves? Once nutrients are broken down and made available, they may be stored in the soil's nutrient reserves. Humus and clay are responsible for almost all nutrient storage in any soil. As a result, soil with high levels of clay and humus has a tremendous ability to store nutrients for future use. How nutrients become available. Most nutrients come from the rocks that weathered down to become parent material and eventually mineral particles. Organic matter supplies many of the same nutrients plus nitrogen, which rarely occurs in mineral form. Organic matter is the remains of animals and plants, which contain many different chemical elements in their cells. As microorganisms break down organic matter, these elements are returned to the soil. Nutrients can also be supplied to the soil as fertilizer, limestone, and other rock dusts or compost. Nutrients have to dissolve in soil water before plant roots can soak them up. The water clinging to soil particles and partially filling pores dissolves nutrients and transports them through the soil. How nutrients become unavailable. They may be temporarily withdrawn by plant roots for use in building new leaves and shoots. When plants die and decompose, these nutrients are returned to the soil. Nutrient depletion occurs only if plants are harvested and completely removed from a site. Soil organisms and microbes also remove nutrients, but as with plants, this is temporary. The elements in their cells are eventually returned to the soil when they die. Chemical reactions in the soil can cause nutrients to form compounds that don't easily dissolve. This essentially locks up nutrients out of the plant's reach. This diagram illustrates how a variety of factors interact to affect the supply of and demand for nutrients in the soil. The soil solution is water and nutrient ions. there's a cation exchange of absorption and chelation where soil nutrient reserves to and from the soil nutrient reserves, humus and clay. There is decomposition and uptake to and from organic matter and microorganisms. And there's also uptake by the plants, but the plants return their residues to the soil through organic matter and microorganisms. Then we have weathering, dissolving, and locking up of the nutrients. Weathering the soil minerals from the parent rock back into the soil solution, and soil minerals from fertilizers and rock dust like limestone and granite dust dissolve into the soil solution. But locking up occurs when mineral compounds don't easily dissolve. What controls nutrient supply? Soil moisture. In order for nutrients to dissolve, water must be present in the soil. Too little water makes it hard for nutrients to dissolve and move through soil channels. Too much water washes or leaches many of the nutrients out of the soil entirely, transporting them to streams or lakes and eventually to the ocean, where they're of no use to plants. Soil air. Soils need good structure, abundant pores and channels to carry both water and air. In addition to harming plants, roots need air to survive, and harming soil organisms, the lack of oxygen in waterlogged, compacted, or heavy soils changes soil chemistry. Lack of oxygen promotes the locking up of some nutrients. It also robs soil of nitrogen by promoting conversion of nitrates into nitrogen gas, which then escapes into the atmosphere. Soil pH. The pH of soil has an even bigger effect on soil chemistry. Either acidity or alkalinity can bind up many of the nutrients at once. Improper pH is the most common reason for nutrients present in soil to be locked out of the soil solution and therefore out of the reach of roots. Soil life. Microbes. Microorganisms are largely responsible for breaking down organic matter to release the nutrients it contains. During this process, microbes produce organic acids that dissolve rock and mineral particles. They therefore change the soil chemistry on a very small scale, speeding up the weathering process. When soil conditions are good, the organic acids they produce can even dissolve some locked up nutrients. Temperature. Since temperature affects microbial activity, it also affects nutrient availability. Warm temperatures increase activity, speeding up decomposition. Cold temperatures greatly slow down activity and therefore slowing the release of nutrients from organic matter. Plants can experience a temporary deficiency of phosphorus or nitrogen in the early spring because microbial decomposition in the cold soil is so slow that it can't meet the plant's demand for those two nutrients. Nutrient interactions. Nutrients may interact with each other to interfere with plant uptake. Too much calcium from overliming can cause an artificial potassium deficiency, for instance, and too much potassium keeps plants from using calcium. It's the balance of nutrients, not just the nutrients themselves, that's responsible for fertility. Testing your soil. The materials needed for this is a soil test kit, making sure all the equipment and the testing equipment is clean, distilled water, a clean trowel, a small plastic bucket or bowl, clean and dry, a sieve with 1/8 or 1/4 inch mesh, that is optional. Easy-to-use soil kits are available from garden centers and catalogs for testing your soil. The simplest measures only pH, but most also measure nitrogen, phosphorus, and potassium. The least expensive kits are also the least accurate, but if you follow the directions on a more sophisticated kit, your results should be fairly good. While these kits don't provide as many details as professional tests, they tell you something about your soil, and they're fun to use. You get results instantly instead of having to wait 6 weeks or more. You'll get better results if you supplement kits with more accurate professional tests every few years or so, or best of all, with close observation of how your plants perform. The first 3 steps are essentially the same ones used to prepare for a sample for a professional test. Some labs require slightly different methods, so be sure to follow the specific directions given by your lab. Sidebar: hints for success. most accurate results, especially where water is very hard or soft. Use distilled water for all tests. You don't have to go out and buy it if you know anyone with a dehumidifier. The water dumped from a dehumidifier is distilled and it's free. Use distilled water to rinse out your test tubes when you're done also. Do separate tests for various garden areas, the lawn, the vegetable beds, and the flower beds. Test while soil is moist, not soggy, wet, or powdery dry. Cold soil will give low readings for nitrogen and phosphorus. Avoid testing unusual spots such as dips or next to a compost pile. Step 1. Clear away plants and thatch, leaves, and other litter from the soil surface. Dig a 6-inch deep hole in the garden bed. If you're testing lawn areas, a 4-inch hole is more than deep enough. Step 2. Carve a thin 6-inch long slice of soil from the side of the hole and place it in a bucket and dig 4 to 6 more holes evenly spaced over the test area. Remove a slice from the side of each and place it in the bucket to create a single average sample. Mix your samples well and break up as many crumbs as possible. Remove any large bits of plants or pebbles. You may find it easier to sift the mixed soil to remove larger particles and ensure the remaining material is small enough to fit in the kit's test tubes. Follow your kit directions carefully for the amount of soil and the amount of indicator chemical to use for each test. Mix as directed, allowing to settle for a specified amount of time. Compare the test tube to the colored chart supplied with your kit. Master gardening tip: getting a professional soil test. A professional soil test is a good idea when you start a new garden. Testing periodically, every 4 or 5 years after that, lets you know if you're on the right track. You can have your soil tested either by public, state, or private laboratory. To locate a state lab, call your local cooperative extension service for information and prices. The cooperative extension service may be listed under county, state, or federal government in the phone book. Public labs. Most state labs want you to use their kit for collecting samples. Others have specific requirements for how to collect samples, so be sure to follow these for accurate test results. You'll get the best results from your own state, as recommendations will take local soil types into account. Be sure to tell the lab how you intend to use the soil being tested, as lawn, vegetable, or flower garden. Private labs. If you want a more detailed soil analysis than that provided by most state labs, try a private lab. A list is provided later on in the book on page 205 in the appendix. Be prepared to pay more. In addition to testing, these labs provide outstanding, thorough, customized reports. Some offer hybrid recommendations using both organic and synthetic fertilizers for soil improvements. Most will provide strictly organic recommendations if you request them. A few offer free consultations after the test.